Thank you everybody for coming. OpenStack 101. We have Twitters, and then this is the link to the Meetup. I'm actually filming this. After I get a chance to go home, clean it up, I'll post the link on there, put it on YouTube. There were a few folks that couldn't make it tonight that asked me to go ahead and record it for them and get it on there. Sponsors are Geekdom for hosting us. They provided pizza and beer, and they're altogether awesome. I plan being here quite a bit. Morantis and OneCloud are two systems integrators. A lot of my slide content actually came from friends that I have in both of those organizations. And then my background, which I'll cover real quickly, I came from Canonical, and so a lot of my knowledge around OpenStack and a lot of the content came from there. This is my background, primarily entrepreneurial. I built an e-commerce site in 2007 and sold it. I worked for Rackspace for about 4 years. When OpenStack was open source and released into the community, I worked with the Rackspace Cloud Builder team to go out and get some of those early builds out into the ecosystem. And a lot of them were actually, they were designed and coding challenges, as opposed to, let's go out and deploy a mature OpenStack environment for you. Most recently, I worked with Canonical, helping customers design and deploy Ubuntu OpenStack, and now I'm a consultant doing the same thing independently. And this is actually one of the highlights of my time at Canonical, going out there, and Elon wasn't there, oddly enough, but I did get to tour the rocket ship factory at SpaceX. That was awesome. This is why I get up every day. This is actually better than an About Me slide, because this is everything to me. Been here in San Antonio for about 7 years now, and so we get out a lot, camping, hiking, stuff like that. This kid's more trouble than he looks like. Okay, so OpenStack. So the challenge I faced with an OpenStack 101 is OpenStack, people spend weeks going to boot camp, paying a lot of money to deep dive into OpenStack. My approach, I was like, well, I can talk about the business case behind why people are deploying OpenStack, the community, the code, deep dive into messaging system and queues. Literally, the sky's the limit, and we could spend all day on it. So, in the interest of an hour, I thought, how can I go a mile wide and an inch deep and get everybody level set with an understanding of what OpenStack is and what it looks like. So what I've decided to do is actually veer away from this a little bit. I'm going to go over the history a little bit, just to make sure everybody understands the history of OpenStack, how it's conceived, why people are using it, a little bit into the architecture, a little bit on how to deploy it, and then beyond that, I'm actually going to pull open the dashboard on my laptop and start playing around with the dashboard. One thing I realized in going out to a lot of sites, working with a lot of customers, is sometimes I would leave after 2 hours talking about OpenStack endlessly, and I realized that none of them had actually ever seen the software running. Nobody had ever seen the dashboard. It was vaporware. We were talking about things that may come to be at some point, and seeing the software work is an altogether different experience. It's also nice when it works in your laptop, so I'll kind of show how to get that going on your own. So I'm going to bypass all of this. What do you think about the cloud stuff? Because this is the reality is it's pretty foggy. The best definitions I've seen is put out by NAST, and that's because they actually break it out into the different types of clouds. So there's the deployment models, your public, private cloud, hybrid, which is a combination of the two. So this is going to be, actually Rackspace is going to offer both of these. The difference is going to be, is it on-premise or off-premise? And that's one of the primary reasons why OpenStack was actually released into the ecosystem, so that Rackspace could get a development community, the muscle of a development community, open source community behind OpenStack, but also get this cloud technology that they want to use for their public cloud into the hands of people within their private clouds. And the ability of this hybrid to burst from your private cloud, where you're running highly secure, maybe highly customized workloads, and then to be able to burst those workloads into a public cloud, that's the dream, or at least that was the dream 4 years ago, and it's now being realized. In terms of service models, everybody's used a SaaS application. I would argue that Facebook's a SaaS application, but more realistically, WebEx, Salesforce, where software just runs. You don't have to worry about what's underneath it. Platform as a service, very similar in terms of you don't have to worry about the hardware or maybe if it's in fact running Apache or some underlying technology. You drop your code on it and you watch your code grow. This is a developer's dream that doesn't necessarily care about the underpinnings, and they want somebody else to support that and maintain that. Infrastructure as a service, that's largely where OpenStack is at. It's going to deliver that on-demand infrastructure where maybe you're going to take control over your own virtual machine and you're not worried about the hardware, network, and storage that's underneath that virtual machine. The essential characteristics, and we'll talk about these here in a bit as we take a look at Amazon and then contrast that with OpenStack. You have to be able to measure services. If I'm going to log into somebody's public cloud, right, they have to understand how to bill me for it. We have to be crystal clear on how I'm going to be billed for it. And it's the same thing within an internal IT group in that organization. The ability to charge back, show back, right? That's crucial with adopting a cloud model. I sat with a CIO. It was a very large retail that probably many of you have shopped in within the last week. And he said, I don't really care how you're going to grow my resources, right, or how they're going to be consumed. I want to know how to get them back, right? After they're done using it, how do I get those resources back so I can give them to somebody else? Or maybe I don't have to pay as much CapEx for all this hardware. And the way you do that is by charging somebody for what they're using, even if it's an internal team member. Because now, if my department's getting charged, suddenly I care about how much resources my department is utilizing. Rapid elasticity, I would argue that's the only reason to use public cloud. I think I'm actually in the majority on that, because public cloud isn't necessarily cheaper, right? Maybe if you have a couple VMs, it's cheaper. But if you're deploying real resources at scale, public cloud is not cheaper than a private cloud. Where it's cheaper is if you're scaling up and scaling back consistently. You don't have to pay for where you are at peak with all that hardware. You only pay when you're using it. Other than that, you find the mean and you're paying somewhere around the mean. That difference between the mean and peak, that's your savings, and that's your reason for going to cloud. It has to be on demand. That's why there's so much credit card creep, right? People going out and deploying services on top of Amazon, going around the IT group because they don't want to wait, submit a ticket and wait 2 to 3 weeks. That might even be fast for some organizations for the server and the configuration to be in place. Network access, obviously, and then resource pooling, right? There's economy of scale. That's how cloud providers make their money, is over allocating those resources and extending those resources to a lot of different people. Now suddenly where I gave you a dedicated server where you were paying $800 a month for, now I can give you these VMs and charge you for it. Oh, and if you're not, running the CPU at 80, 100%, I'm going to go ahead and sell that again to this guy over here. And that's how cloud service providers make money. Why cloud? I covered a lot of that in the other slide. I would actually argue, it's in my deck, but I would say it's not necessarily to reduce the overhead of IT. A lot of people are looking to automate and run their infrastructure at scale. It's not to reduce the IT, it's to do more with less. It's to be able to scale that infrastructure and do more. It's to build against a new development paradigm such as DevOps. It's to automate. I want to point out here that a cloud is not necessarily virtual managed hosting, and it's not necessarily VMs. A lot of times the conversations I'm having are around how is OpenStack like or not like VMware. Right? Now VMware has their cloud piece, they have vCloud now, but a lot of times people are comparing it to something like vSphere. And the two are very different. I mean, that's semantics about what makes a cloud, but when we go back to the previous slide, it's the self-service provisioning, right? It's the ability to pool those resources that you can't necessarily do without an IT person getting involved on VMware. And then that's it, it's self-service. I'm going to bypass Amazon in the interest of time. the short of it is they've been incredibly successful with all of the stuff that we're talking about. When we talk about OpenStack, OpenStack is basically, it's fair to say, mimicking what Amazon did with their infrastructure as a service. Rackspace also immediately came to market as Amazon was growing and growing in power. And Rackspace did a great job of working with NASA to get OpenStack out there to compete. This is actually, this slide I used to show about 3 or 4 years ago. That's when Gartner put it out. I just use it today because they were so accurate with it. It kind of restored my faith in Gartner a little bit. They're dead on that these are the major ecosystems. Microsoft, that was before Microsoft, Azure was really even out there. Microsoft is building a public cloud, or has a successful public cloud, and then they arguably have a private cloud as well around Hyper-V. And then the ability to use both those resources in tandem is huge. And they, by the way, also contribute to OpenStack, right? Because they have a little operating system that they want to run on top of OpenStack. VMware as well adamantly came out against OpenStack early on because it is a threat. Now VMware is doing a fantastic job. They have a VMware supported OpenStack. They contribute to the ecosystem. They have some SDN services around Nicira, a company that they purchased that has plugins into OpenStack. And then of course there's Amazon. But what makes all of these different is that these guys are all proprietary, where they're feeding into OpenStack and they're providing the code. A lot of that is around them being able to provide proprietary plugins into OpenStack and monetize on it, right? And none of us, maybe some of us work for nonprofits, but that's okay. You need to monetize on it, but I think it's more to draw from OpenStack and not necessarily contribute to OpenStack. So the reason people are moving towards OpenStack, so this is kind of a why statement, right, is that there's no vendor lock-in. That's changed a little bit. There are certainly some ways of locking people in by providing really nice deployment tools that make it compelling to use those deployment tools to deploy OpenStack with them. That's a bit of lock-in. I would argue that anybody looking to deploy OpenStack should steer clear of that type of scenario and move towards more of an open source deployment tool, learn the skills, or pay a vendor to deploy it, but deploy it with tools that do not lock them into a particular vendor, and that gives them freedom of choice as their cloud begins to scale up. It's a platform that works for public and private clouds. There's obviously low costs associated with buying OpenStack. Is free, but there is no free lunch, right? Because you still have to hire people with those skill sets, or send those people out to acquire those skill sets and then bring them in-house. I can tell you I've been involved in projects, so this is the demand of OpenStack. I've been involved in projects where, as the day after we left the site in deploying OpenStack with that team and doing the knowledge transfer, that those team members moved on to other roles in other companies with those skill sets, immediately putting those skill sets to work. And that is the vacuum that is OpenStack, right? The skills, go on LinkedIn and look for jobs where there's, I'm not advising finding a job, but you go on there and I guarantee that there are hundreds of OpenStack jobs available. And that's why there's so much training going on right now. There's a lot of organizations, Rackspace being one of them, does a tremendously great job of training people to run OpenStack, because that's one of the primary costs, is cost of labor. Storage, I'll talk a little bit about these components. Basically block and object storage and how it connects to OpenStack. And then flexibility. This is a kind of catch-22. OpenStack is incredibly flexible, meaning there's a lot of different projects and they all feed into each other. And you can deploy OpenStack many different ways. I think last time I saw a study put out by the foundation, when somebody wants to deploy OpenStack, there's 250 different decisions that they need to make while they're deploying OpenStack, right? So that's the vendor that they're going to use for hardware, operating system, network,
It's how they're going to configure it, where they're going to put different services. The beauty, though, and why I say catch-22 is because if I build OpenStack with a small business case in mind, and my team begins to use it and consume it, and it's highly successful, I can use that same infrastructure and I can begin to scale that out horizontally. So you're not necessarily, unless you go towards a proprietary solution, you're not necessarily in a trap there, but you do have to be careful because some of those early design decisions can cause mistakes or issues down the road. Overused term of the day, DevOps, but it's accurate. It's what most people want to do, right? You want to develop your code, deploy your code. Traditionally, you then turned around and said, "Here you go, operations team. Code's perfect. Run it." An operations team, if it breaks, is stuck with it. So DevOps is more of a combination between those two, where you can run more of an agile development process where you're deploying the code, you're handing it off to operations, and many times it's one and the same people, and then you're continuing to iterate that code in continuous integration and maintain it. I'd say OpenStack itself is a perfect model for it, but OpenStack delivers the APIs, the self-service, the ability to script out your deployment in such a way that it feeds into the DevOps model. I already talked about self-service, but that's what teams within organizations need, is the ability to consume that organization's resources on demand. Let's dig into OpenStack a little bit more. So OpenStack, at its most simple definition, is these three projects. One being compute. That is hypervisors and virtual machines, the ability to spin up virtual machines on demand, at scale. It's also one of the most complex of the OpenStack projects. Codename Nova. Networking, codename Neutron. I say codename and I feel like a secret agent. Is also highly complex and has some of the most, when you look at vendors that have been duking it out, like Cisco, Arista, Juniper, in the enterprise for years, everybody wants to control the networking piece. So I don't envy the project technical leads that run the networking piece, because a lot of those companies, while contributing to Neutron, also want their proprietary code to be what's plugged in and running. The beauty is that it gives consumers the freedom of choice. So that's something that I really like about it, and a lot of functionality. SDN, NFV, network function virtualization, software-defined networking, that's its own subject, and you could spend days or weeks on it. And then storage, right? With big data. I read the other day Facebook adds something in the neighborhood of 0.5 petabyte a day of data to their infrastructure. That's just surreal to me. There, of course. So I've heard OpenStack. So it is middleware. I've heard it called a cloud operating system. I don't like that term, cloud operating system, just because it almost confuses with existing operating systems that you still need to run OpenStack. I get the term. I prefer Fabric Controller or Cloud Orchestration, because I think that more distinctly says what it does. The reason I say that is, I don't have a slide for this, but you can see compute, you have your hypervisor, and then you have your virtual machines. Well, picture OpenStack as a stack right next to it that understands what hypervisors are here and understands what virtual machines are here, and then decides where new virtual machines go as they're being spun up. So you take this and you multiply this times 1,000 across your data center or multiple data centers, and you need something as a fabric or orchestrator that knows where all that is. And I'll pull up the dashboard here in a minute, and you can see the reports that you actually get with it. And then the other half of OpenStack is the community itself. It was released in 2010. Joint venture between NASA and Rackspace. NASA provided the Nova, the compute piece. Rackspace provided Swift, which was already put to use, storing petabytes of data in cloud files. Swift was the most mature at the time because Rackspace was running it in production, and tons of work went towards Nova. I would argue Nova, it's a different animal. I wouldn't even compare the two, but both are highly mature today. There's 6-month development cycles. Slide coming up on that. This is the way that the foundation was created. There's basically 3 different committees or groups. There's the tech committees. You have project technical leaders that are responsible for Nova and Salometer and Swift and the different projects, and they work with the tech community who are providing commits to make the projects that much better. You have your board of directors, various levels of board of directors. I don't get too much into the politics. I just like that there's a lot of different people that contribute to the organization of OpenStack, and that, as far as I'm concerned, means OpenStack is in good hands, because you don't want one organization to be too overly influential within OpenStack, because there's just too many different types of organizations that utilize it and utilize it for different purposes. So you get the variety there of community elected individuals, people that are paying a lot of money. They can bring individuals onto the board, and then there's the real I'd say the real consumers and the real people who benefit from OpenStack, and that's the community. And so there's a user committee. They're all over the world. They have regular meetups, and they provide feedback around what should be developed within OpenStack. What services should be deployed next, and what should be fixed. I'm going to move through this real fast. When it first started, that was basically my slide deck of the people that are involved. But these are basically sponsors. These people paid a ton of money to be platinum sponsors. It's basically your regular, valuable metal nomenclature, where you have platinum, gold, silver, and it's continued to grow. It's hardware providers, systems integrators, consumers of the hardware or software. It goes on and on. OpenStack. Sorry. I'm going to speak up. So, OpenStack, this is the nomenclature OpenStack follows. You'll see it's in alphabetical order, A through K currently. Every 6 months there's a release. What they do is the site of where the design summit, which is going to discuss what's going to go into the next version of OpenStack, they find a city or a county, and they name the version after a city or a county that's generally in that area. You can see a lot of the early development happened right here in Texas with Austin and Bear. Diablo was the first production release back in 2011. The really interesting thing, and there's actually a summit, Juno Summit's about to happen in Paris next month. But the real action happens on this side, where you see it started with Nova and Swift, what we were talking about with NASA and Rackspace, and then you got Glance, which it's basically it's a database that handles the images that are made available to users of the cloud, and then it froze, and then you have your production release, and then boom, you start having all these projects that were incubated and then tested, validated, and released. So then you get Horizon, your dashboard, Keystone, your authentication, Quantum, which became Neutron. There was a copyright issue. Quantum became Neutron, it's the network piece. Cinder is block storage, Cinder block. Salometer, measuring, metering, basically pulling data out of the cloud to feed into a billing system or monitoring systems. Heat, you're starting to get some auto scale components, Trove, database as a service. I can only imagine, so this has been 4 years. I can only imagine what it's going to look like 4 years from now. It'll probably be its own slide. These are project contributions within Icehouse. So right, it went Grizzly, Havana, Icehouse. You can see a lot of the lion's share of the work is still going into Nova, because that's the monster and that's the piece that everybody uses.
then Neutron, the networking piece, and then the rest of the projects themselves. The thing that was interesting to me is in conjunction with this slide, the data was there that the total, how do I phrase it? The work that was contributed to get OpenStack to where it's at today represents about 249 man-years of labor to get it to where it's at today. So that's everybody, like many hands make light work. I think many hands still made it just a ton of work, but it's incredible at that much work, and that's how fast OpenStack is growing. I would say it rivals any other technology that's out there today in terms of the amount of resources that are going into it, to develop it, to mature it. This was the result of a survey that was done at an OpenStack Developers Summit. The reason I want to show it is because you can see the variety, right? When I was talking about vendors and choices and options that people are taking, these are results on what people are actually using. So these aren't just vendors saying, yeah, everybody uses us. This is what people are actually using. I think if you just took a slice across the top and say that's what I want to do, I think that would be incredibly safe because that's what a lot of people are doing today. That's not to say that's the direction you have to go. I've had a lot of conversations with Cisco, and they have a rapidly maturing solution. They have a lot to offer the market. But when you look at, for example, storage, look at all these storage vendors that people are using. And each of these has to contribute code and plugins into the OpenStack community. These are all ways to deploy OpenStack. Here's Puppet and Chef. These are machine configuration tools. Basically, they make it so that OpenStack's hard to deploy. And so what they make it so that you deploy it once, you've had it scripted out, it's basically documentation. Now I can take that script and I can deploy it and run it again here. So I have my test and dev environment, great, everything worked fine. Now it's my sandbox, right? And now I go ahead and drop it into beta or production or whatever we want to do. So these automate that and rapidly speed it up. What I don't trust here in the data is that DevStack is number 3. And so that says two things to me. Either people are using DevStack for production and they shouldn't. DevStack is a very simple way to deploy OpenStack. I'm running on my laptop right now. Or people are still, or these are developers that are just getting their feet wet, or maybe people who are just getting their feet wet and playing around with it. So that's where I kind of look at this data and I start to go, okay, well, are these people running at scale in production, or are they just getting going on it? And then obviously there's a lot of Linux distributions that you can utilize. So what it equals is choice. Here's a link to DevStack. Here's a link to TriStack. DevStack, you need VirtualBox. You're going to deploy an Ubuntu, Debian, Red Hat image, CentOS, and then deploy DevStack on top of it. But TriStack, you can just hop onto the website. I think it's hosted by RDO. You can just hop onto the site, and if you have a Facebook account, it's this little social media site, and they'll go ahead and they'll use that as authentication into TriStack, and you can go ahead and keep going. And there were some other tools for deployment. I'll post a link to the slide deck if I'm going through some of these fast onto SlideShare. I'll put the link onto the Meetup. So as you look at the conceptual infrastructure as a service architecture, we've covered a lot of these pieces that are needed. How am I doing on my video? So so if you're a service provider, or even if you're just a company that offers services to their internal teams, you need some kind of billing engine, you need identity, you need to establish somebody is who they say they are and what they have access to. And so that's all the integration component. Then you have the presentation layer, which is going to give people access to an API or an end user dashboard. And keep in mind that it's all different types of people that are accessing this infrastructure. You have your end users, you have your admins, you have your developers. They're all going to use different tools. You have your logic layer, which is going to provide orchestration, scheduling, what resources are going where, what's a good algorithm to define what should go where, policies for what has access to what. Images need to be available for somebody to spin up a virtual machine. They need to understand what images they have. You need to be able to keep those images up to date. And then, of course, logging. And then you have to have resources available, so compute, volume, and networking. And then you have to have your admin API, because all your developers, all your people, your admins probably have their own tools, and so they're going to want to pull that data into their own system, and then you need to be able to monitor it and make sure everything is up and running. This is how OpenStack overlays on top of these. And really, I won't go into all of it because I think it beats all of them, with the exception right here. Right, that's where there's a question mark. Right here, arguably too, somebody has the option of using Horizon or building their own catalog or portal. OpenStack doesn't by default offer any sort of billing. It offers telemetry. It offers the data. A lot of people have their own billing mechanisms. It feeds into that. There's people in the community that do provide billing, but you know, out of the box, it doesn't necessarily provide it. I think at this stage we're probably familiar with most of this nomenclature, right? Your host is your physical server, your guest is your virtual machine, your node, for at least in this context, I'm referring to a physical server. And then you have really three primary nodes within an OpenStack environment. Your controller node that has all the services that we've been talking about so far, right? Keystone for authentication. The OpenStack utilizes a messaging system and a messaging service called RabbitMQ. And then you have MySQL databases that store the state of the different services or of the cloud itself. And so you need to run those somewhere. And so those are all going to be home on the controller node. The beauty of that, you have abstraction on top of abstraction. It's like Inception, right? Where you have a service, and then you have services inside of that service. The reason that you have that, and then messages that pass between them. The reason you have that is because that is horizontally scalable, right? The old model, sorry for like Oracle or any mainframe, right? It traditionally put more RAM, put more CPU behind it, right? It needs a bigger processor, it needs more processors. It was a vertical stack. That's how if you needed more resources, that's what you did. You just made your server bigger. Now everything is horizontal, right? Scale up, scale back. That's the only way to keep up with the way resources are being consumed nowadays and the way that data is being consumed nowadays. Refer back to Facebook adding half a petabyte of data a day. I would argue you probably could you run that in an Oracle database? No. So I mean, it's unrealistic at the amount of bit data that we deal with. Compute nodes, those are almost like an ESX. Well, they are essentially the hypervisor, right? You can run ESX, Zen, KVM. They're the physical machines that you're going to run your virtual machines on top of. And then you have your network nodes where you control the network, spinning up the network, controls what, where, what has access to what. In the interest of time, I'm going to move through a lot of the stuff because I think we've been covering a lot of these along the way. This is a very simple reference model for a two-node build of OpenStack. You have a single controller node, and you have a separate compute node. And so what we're looking at is using the network. We have three networks that have been created. We have a management network that the nodes are using to communicate, that the various services are communicating with each other. You have your public network where you may have various private networks. There's a concept of floating IPs, which I'll get into. I want to show the dashboard of that, so I'll wait for that. And then we have the public network as well. So using Neutron or even Nova network, you have the ability to create these L2 and L3 services within OpenStack, firewall as a service, load balancing as a service, and it's going to do all that across your network. This controller node contains Keystone, Nova, Neutron doing L2, L3, Cinder, and Horizon your dashboard, and then you have your compute node where you're spinning up and adding additional nodes as your cloud begins to grow. This is actually, it looks different, but this is the same picture. So you have controller, compute, controller, compute. And when I was referring to the different services that run inside of them, right? These are all services that are going to run inside of your bare metal controller. I think this will soon be a thing of the past, but one of the challenges associated with getting comfortable with OpenStack is understanding that what needs to communicate with what needs to be running when and where. That's one of the complications with deploying OpenStack. And this is this is two servers, right? This is a very simple representation of OpenStack. All right, dashboard time. That's what I've been trying to get to here. Alright, so I'm running VirtualBox, and on top of it, I'm running Ubuntu 14.04, trusty tar. All I did is I went here, devstack.org. I deployed a fresh build of Linux. I had to install Git, ensure that I could get SSH credentials, and then I went over here and basically grabbed a fresh deployment or the most up-to-date build of DevStack, and then I went ahead and said change directory to DevStack, and then go ahead and deploy stack.sh. And what it did is it kicks off this build process depending on the resources that you have on your machine. It'll take anywhere from, 4 to 500 seconds, and it goes through the process, and you can go through, you'll obviously have a terminal open, and then you'll watch the build take place. And then at the end of the build, it's basically going to say, here's your IP address, and here are your credentials. And then you're going to go to the IP address, and in this case it's 10.0.2.15, and then I'm going to log in. I'm logging in as the admin, and I've already created the password. I know I went through that really fast. It's all there on devstack.org, and it's actually quite simple. And it's exciting because on your machine at home, you can deploy OpenStack and begin playing with it immediately and see what it's capable of doing. So I just logged in as the admin, and basically what that means is, over here on the left-hand side, the nomenclature that OpenStack uses, so a project can easily be replaced with tenant. And so if you think about this as a company that's paid for my service, and these are the resources they have access to that I've allocated to them, they would find that here. If it's my marketing department and they're spinning up various marketing related websites, and I want to give them a certain amount of resources and a small number of images that they can choose from, this would be called project. And then as an admin, I actually have access to more resources in terms of what's available from within the is how I create identity is how I create new projects or tenants or additional users. So I'm going to go ahead and go in here to overview. I just didn't see. There we go. So I've already created a virtual machine, and you can see that there's this is all in Django. It's all customizable, or people can use their own proprietary or their own portal. They can create their own portal. But already it just has by default some really great visuals of what's actually running and what this tenant's running. So if I'm an administrator of this project, I can hop in and say, okay, I can see I've already used 2 instances, 2 virtual CPUs, 2 floating IPs, 2 security groups, one volume. And we'll go into what these things are because we're going to create a VM here in a second. But just immediately I can see what's available to me. And then as I scroll down, I can drill down into deeper reports. Obviously over time I'm going to be running hundreds or thousands of virtual machines, and so I need to be able to drill down in there. So I'm going to go ahead and go over here to instances. And as you can see, I've already spun up a couple of instances, but in the name of science, we're going to spin up a third. Nothing like a live demo to freak me out. So OpenStack uses the concept of availability zones. If anybody's used Amazon, you're familiar with availability zones, where an availability zone is typically is typically a group of resources that is isolated for failure against other groups of resources. So I might have a data center in Phoenix and a data center in Washington, D.C., and I might create 2 availability zones out of those, as opposed to trying to network everything together. I want those to be isolated, and then I can choose which availability zones I want to spin up resources in. If you log into Amazon's control panel, it's the same way. You go to the top right, you drop down, you have access to all these different data centers, you click on the data center, and then you deploy resources within that data center. So each of those are availability zones. A lot of folks start with one availability zone, and then that's how they grow. And then that's how they guard against failure, because now if I have a web application, I can deploy it in one availability zone, then I can deploy it in a second availability zone. I'm looking at everything through one console, right? It's all in one place, one single pane of glass, but really it's geographically distributed across multiple data centers. I'm going to go ahead and name this instance. Let's just call it test 1. OpenStack uses a concept of flavors. You have the ability as the administrator to go in here and define what a flavor is in terms of the size of a flavor. Basically what it is it's a basic layout or description of what would represent hardware on a hardware environment, but what represents the resources that are going to be utilized by a machine or instance that is running with that specific profile. And so in this case, I'm going to use a nano, which you can see, well here, I'll go ahead and show you what a large looks like over here on the project limits on the bottom right. See how that kicks out? It's showing blue is what's currently being used, green is showing what's going to be utilized if I go that direction. I'm just on my little laptop here, so I'm going to go nano, it almost uses no resources. How many machines I want to run, and then my boot source. You can restore from a snapshot, which is basically a point in time view of a particular machine. So it can be great for essentially serving almost as a backup or a disaster recovery. You regularly snapshot an instance, and then you have the ability to go in and restore from that snapshot pretty rapidly. I'm going to go ahead and say I'm going to boot from an image, and then I'm going to load a Ceros image. It's literally a small version of Linux that's designed just for this. You can see it's like 24 megs is all that's necessary to run it. I'm going to go to access security. I have the ability to insert key pairs for SSHing into the machine as it's being built. It's going to be dropped in there. There's a concept of security groups, and what a security group is essentially predefined security rules that will be dropped into the machine when it's created. It's going to be things. I'm sorry, it's using. I forget the name of it. Like IP table rules, where I can go in and I can say, port 443 is going to be open on this machine. So I might have a security group for my database servers. I might have a security group for my web servers or for my mail servers. They're all going to be different. Now, once I've created different security groups, I can now, if I'm spinning up another web server, I can say, this is my web server security group, right? Now port 80 is going to be open. Port 443 is going to be open by default. Maybe I'm opening some, open to a private network to communicate with my database server, something like that. I can do that as I'm creating the machine. I can drop in custom scripts about my user. And then the disk partitioning. So this is going to be the persistent disk space that's used by this machine. I'm sorry, I should say ephemeral, right? It's persistent to the point where the virtual machine is running. When I shut the virtual machine off, it's gone. It's no longer being tied up and used by that particular machine. So I'm going to go ahead and go automatic. I'm going to hit launch, and what we're going to see is we'll see the machine status over here. There you are. So right now it's no state, it's building. It said scheduling there for a moment, so the scheduler was saying, where do I have resources? Oh, you look like a good spot. Okay, I need credentials, and do I have access to this, and do I have resources available? And then it's going to go through and build a machine. And as you can see, that happened incredibly fast because of the small size of the Linux machine that I spun up, small amount of resources I needed, and went really fast. It was already given an internal IP address. You can see that the size is in nano. It's running in the availability zone that I specified. It's been running for 0 minutes, and now I have the ability to do various things with the machine. So I mentioned floating IP addresses. I'll actually go ahead and hop in there and show you assigning. So the nice part about a floating IP is, let's say I'm on a large shared network, and I'm spinning up a bunch of web servers, and then I'm going to spin up a load balancer over top of that. I may want to, as I go from a single web server to a load balancer, maintain that same IP address. Because it's a shared network, I'm probably doing some kind of network address translation. I'm pointing traffic towards that particular IP address. And so I can literally take the virtual machine that IP is assigned to, I can move it to a load balancer on the fly and begin distributing load across multiple virtual machines, all without having to go in and configure the network or make any changes to the network. It's all programmatic. When I'm going in, that's why it's called a floating IP. I just move that floating IP to where I need it to be. I can edit the instance, changing the size of it, edit the security group. I can get console access right here from the dashboard, view logs associated with it being built or status or updated. I can pause it, suspend it. That has to do with whether I want to maintain resources of that machine or do away with, release those resources for the time being. I can resize it on the fly. So again, back to that scenario, I've got a web head that's it's getting killed, right? I got slashed on it, or something happened where I've gone viral. Well, I can take a snapshot of that machine, create a new machine, put a load balancer over top of it, move that floating IP address. This machine I've made bigger, hopefully, because I thought ahead, and now go ahead and resize this machine, right? And what I've done is I've just scaled up to a redundant architecture, load balancing across multiple web servers, all right here from the dashboard. In the past, if I was using physical machines, something like that, assuming I had the machine available, might have taken me half a day if I didn't do it. So that's the rate of speed that we're operating at now with cloud methodology. I can reboot it, I can shut off the instance, rebuild, or terminate the instance entirely, destroying it and freeing up those resources. I'm going to go ahead and go in here and associate an IP so you can see that. I'm going to move kind of quickly. I figure I've got about another 15 minutes, and then we can do some questions or kind of break out into groups, and I'm happy to let anybody who wants to drive on here drive. And I didn't open up to associate address. And we're waiting. Okay, sorry, I missed it. It is associating floating IP addresses over here. So I've just assigned 2 floating IPs to it now, where I can begin directing traffic to those IPs. I mentioned persistent storage. We talked about block storage. Adding a volume is the concept that made it easiest for me to understand is basically by adding an external drive to my laptop. I'm basically taking this virtual machine and I'm adding a volume and attaching it to it. The beauty is that's persistent. Even if the virtual machine comes down, that volume is maintained. So what that means, and it's block storage, so I might put data from a database in it because I can dynamically alter that data on the fly because it is block storage, just like the hard drive in your laptop. So what I can do then is, because it's connected to that virtual machine, I can shut off that virtual machine and that volume still exists. Or if I want to move data across multiple virtual machines, I basically dump that data onto a volume, disconnect it from that virtual machine, plug it into another virtual machine, right? all without touching the data, nothing physical, all of it abstracted. So I've created a volume here. I'm going to go ahead and create a new volume. Call this delete me volume. You can write a description about it. Select a volume type, LVM, size, let's say 1 gig. I can choose where my volume source is going to come from. I can grab it from a particular image. I decide what availability zone it goes into, and I say go ahead and create volume. And instead of waiting for it to attach, I can show you what happened on this one. Here, actually, that's really fast. I'm going to go ahead and edit my volume. And so I can grow that volume out, extend it. I can edit attachments. Select an instance I want to attach it to. Test 1, the one I just built. Attach volume, right? No different than plugging that Western Digital external drive to a laptop that I'm plugging into my virtual machine. Now, if I were to log into my virtual machine, I'm gonna show that volume now popping up and being made available to my virtual machine. And then here's all the detail on my volume, and there's where it's going to show up in the file system. These are images that are made available to me by my administrator. There's a lot of image types that can be used. You can see it right here. You know, using Amazon nomenclature, you can use like an EMI image or QCOW2, an ISO, basically a bootable Linux image, anything you can download from Ubuntu website and that you would be able to deploy to your laptop. These are security groups that I mentioned. This is the default security group. I'm going to go in here and manage rules. You can see that this allows ingress, TCP, port 443, right? Random, but I can go here and modify those rules as I see fit. I'm going to bypass orchestration. That's basically heat, is the project name, and that's auto-scaling. And so it's the ability to template out what your environment looks like. And so it's disaster recovery, right? If something happens to your environment and you need to scale it up quickly and then move the data over to it. Or it's rapidly scaling the environment in the event of knowing that you're going to get a lot of traffic coming. And so being able to programmatically, via the APIs, increase the size of that environment. This is the visibility that an administrator has. So that was a tenant. I'm going to look at the hypervisors. So this is, in this case, this is my machine. In the event that I was managing the cloud, I would see a bunch of additional hypervisors that are here. I would be able to see, in terms of managing capacity, how much resources are available within my cloud, and then how much resources that my tenants have utilized. And then that way I can manage capacity in that way. And of course, all this data can be pulled out of it. A fairly recent addition to OpenStack is the concept of host aggregates. So I've talked about availability zones where it's going to be isolated by a particular region. I might plan it based off of isolation in the event of failure. Well, a host aggregate is going to take, basically you're going to take a pool of similar resources and further abstract those from other resources. And where that's valuable is, let's say I've got a pool of really large servers that I want to be my database servers. Well, I have a host aggregate just for those. Maybe another group are old servers that don't have much resources, but I still want to be able to use them for a sandbox or something like that. I don't want to run production workloads on them. I can put those on a separate host aggregate. So it's just slicing up that cloud just a little bit further. These are the instances that are up and running in my cloud across tenants. In this case, I just have one tenant as the admin that logged in and ran it. Volumes, I can define the flavors. So this is where if I'm a cloud service provider, I want to define what my services catalog looks like. The reason that this matters is because you start getting into the science of packing. How are you going to pack your cloud, right? What flavors do I want to make available to tenants? What flavors are tenants using? and how do I want to distribute the load that those tenants are placing on my cloud infrastructure. If I'm starting out as a cloud service provider, right, maybe I just want to make some very small, medium, large, extra large available to my tenants, see how those are used, and then begin to release more flavors and make them available to them. And then last but not least is systems information. What this is showing is the services that are running, what you can't see, what's under the hood, making sure that everything that I just showed you is possible. So what I want to do with the last few minutes is show you what happened when I created that image. I mean, you can see that. So this is what OpenStack. Actually, this is what OpenStack looked like a year ago. It's even more complex today. But this is essentially what happened when I created an image. And this is how OpenStack controls who has access to what, and across different services controls to verify who has access to what, how much they have access to. So essentially, as a user, I logged in and I passed my credentials to Keystone. Keystone checked my credentials against known credentials and handed out a token, right? And then now that token I can use for the session that I'm in there. That token was then used to request a VM within Nova. Nova says to Keystone, are they who they say they are? Do they have access to it? Keystone's like, yeah, it's cool, we have a token, it's good. And then Nova reaches out to Glance and says, I need an image. I want the Linux machine image that that the admin says that I can have. Glance goes, okay, but first let me check your credentials, right? And it says, okay, we're good. Hands out the image to Nova, and then Nova then reaches out to Neutron to create all the networking pieces, all that magic associated that, assigning IP addresses, putting it on the network, setting up the rules that we talked about. In addition is going, okay, well, are you who you say you are? Yeah, okay, cool. Here's the information that Nova needs, and I'm going to verify that it was successful, kick back to the user, yeah, it's successful, dashboard kicks open, virtual machine running, here you go, you have access to it. And so that's what's happening on the back end, the kind of what's unseen within OpenStack. Now, that said, like I said, this is what I'm talking about, is like we can spend hours and days digging into each project and the different services that are available within the project, how the databases are utilized, APIs are created. There's a lot to it, but you can see what I showed you here today is available to you when you get home and you're playing around on your laptop and begin playing with OpenStack. These are some resources that I would recommend. Not to promote Morantis, but they do a great job of putting material out there. I think that's one of the secrets of their success. This is a slide deck. It's 188 pages of talking about message passing and functionality on the back end of OpenStack. You can geek out to your heart's delight. And then, of course, on how to deploy a cloud infrastructure, the different services, specifically around Neutron or Nova. There's quite a bit there. And with that said, I think we've reached the point where the point of saturation there. I think I've been going for about an hour on it. So I'm actually happy I got through that much content within that period of time. So I don't know, does anybody have any questions, or does anybody else want to comment, or did I say something incorrect that anybody wants to call me out on? That's okay too. Ed? No?
Well, the interesting part when you saw all that stuff growing, all the projects earlier that each release had more and more.
Yeah.
A lot of them weren't actually new projects. Just Nova got so big that they split them out. So networking, volume, that was Keystone itself was all once inside of that. So.
Yeah, it's like we were talking about earlier. And to make it scalable, you have to make it modular like that. And you also have to be able to focus people. You can't go, everybody work on Neutron. You have to work on Neutron, or sorry, not everyone work on Nova, work on Nova, and you work on Neutron, right? And, yeah. We're good? Sir.
I usually follow the cloud every now and then. I remember when you had the big four providers,
Yeah.
Microsoft, VMware, OpenStack, and Amazon. What about Google App Engine? Are they relevant at all these days? Or?
I think so. Like I said, yeah, that's an old slide deck. You know, I guess I'm almost ashamed to admit I have not created an account on Google, so it's Google, so they're bound to find a lot of success. They're good at what they do. They're smart. I know that every time there's a price drop within Google, Amazon matches. I don't think if you're Amazon that you even bat an eyelash if ABC hosting provider drops the price of their cloud, even if they're significantly less than yours. So I know that they're a tremendous threat to them. It's what we're seeing. I think we're seeing in the ecosystem what everybody expected, right? You're seeing consolidation. You're seeing IBM buy SoftLayer and make that part of their cloud. You're seeing IBM make a deep investment in OpenStack. You're seeing Amazon create more private clouds and get certifications within the government showing that they can be secure and provide a secure environment. I mean, you're seeing a tremendous HP, not the other day, but very recently purchased Eucalyptus for their technology and interoperability, or the APIs, which, you know, within OpenStack those are quickly deprecating, but with Eucalyptus they're still fully functional, and they have an agreement with Amazon, and now HP has that IP, and then they can begin utilizing that to bolster up their own offerings. And MetaCloud getting purchased by Cisco, and Enovance, a systems integrator, getting purchased by Red Hat. I mean, you're watching all these early players that hopped into the cloud slowly get gobbled up by the people that, why innovate when you can purchase innovation? So
it's an old slide, but don't bother to update it because it's not changed tomorrow.
yeah, exactly. Yeah, thank you. Yeah, couldn't have said it better. Yes,
You
sir.
just brought up a really good point about companies gobbling up other companies. That to me is like one of the biggest benefits of the OpenStack Foundation, is you don't have to worry about Amazon taking their deep pockets and buying OpenStack and squashing it, or stifling development. It can't be done now. If it was simply Rackspace owning it,
Yeah.
then Amazon could buy Rackspace, and sort of like the way, what's happened with MySQL. Yeah, it's sort of free, and Java, it's sort of free, but it's not really.
Yeah.
And you have to be concerned about that. OpenStack Foundation now owns the copyright to all the source code, and it can't be bought and put on a shelf somewhere.
And you were involved at the time when that happened, right? And what we saw was when the foundation was created, I think it was before Boston, and then at the Boston Developer Summit, it just felt like there was just this explosion. The announcement was made, and it was like there's this overall sigh of relief that everybody had made. Dell was there, HP was there, everybody that made these investments was like, oh, Rackspace really is going to do what they said that they were going to do.
Yeah, we said we were going to
could
do
feel
it all along at the beginning when nobody believed it.
Yeah, and now it's under the Apache 2.0 license, so it's truly open source. Any questions? Cool.
Okay, I'll throw one out.
Uh-oh.
So you mentioned the 4 different business areas, and OpenStack being in one of the quadrants. Is there, now you know a little bit about my particular instance that I'm trying to work on, but is there like a critical size that you should start looking towards more of a private cloud or a hybrid cloud environment? I know that hybrid or public and
Versus
hybrid
using
clouds are
public?
way different than like private clouds, but versus a Hyper-V or a vCenter or some of the other offerings for, like you were saying, not clouds, but
I think every use case is different. I mean, I think the reason that people still continue to use a lot of the proprietary cloud technologies is because it's a conversation we had about Oracle today. It's safe. I can go to my senior leadership and I can say, we're buying more VMware, and they go, how many zeros do I put on it this time, right? But they're used to writing that check. It's not a big deal. It's dangerous to be the one of two Linux guys in an organization who walk in and be like, we just heard about this great technology and we're dying to try it, right? They're going to be like, I wrote a check for a lab, have fun, right? When it matures and it's safe, go ahead and bring it back to me. So
what it takes is, it takes serious executive buy-in, and the challenge is sometimes is convincing those executives that it's worthwhile. And I think to your point, there's a scale involved in that, right? If I walk in and I say, here's millions of dollars of risk, and we're going to save thousands and thousands of dollars, or even hundreds of thousands of dollars, they go, ha ha ha, talk to me when it gets like this. Now, if I'm Time Warner or I'm Yahoo, it's like this. Not only is it like this, but now I can beat VMware over the head and say, I want you to be somewhere around here, because otherwise we're going to increase this investment. And they go, whoa, 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 let's not be too hasty. We like OpenStack too. Let's hug it out. So I think it depends on the organization, you know, and the workloads too. Like anytime somebody comes and says, you know, Ben, I want to run Oracle, or I want to run, you know, our ERP, or some of these traditional applications that rely upon a highly redundant server or set of servers to run, I say that's probably a bad fit for OpenStack, right? It's the pet versus cattle discussion, right? And if you're used to the care and feeding of that pet, and if that pet dies, you're going to be really sad and you know, be upset until you get a whole new puppy. It's the cattle situation where, you know, you expect them to die. In fact, that's your business. It's okay if they die, because you're just going to get more and more of them. And so the conversation that ends up being had is, take OpenStack, deploy it in your lab, play with it. Tell the geeky people within your company that, you know, they can spin up a few VMs if they want, and here's the dashboard. Those geeky people walk in and they go, I'm going to use this to test to write my new application. And they're going to cloudify or write a cloud-aware application that uses APIs and, you know, grabs some images and auto scales and uses that network. And they're going to go, this is great. I don't even have to tell IT, haha. And they're going to use it. And next thing you know, your resources are all going to be gone. What I'm describing is exactly what happened with NASA Nebula, and it's why we have OpenStack today. Because then more geeks come in and they go, I hear that you have resources and that you have a cloud and you're holding out on us. I want access to it. And then those guys need to go like, oh, we got to find more servers. And next thing you know, in their office, and then pretty soon in their closet, and then, you know, part of the data center is this cloud, right? And so it's almost this Hunger Games type model of technology. And that's what we've seen with OpenStack within every organization I've ever seen OpenStack in. Is if it's easy to consume, if it's fast, people are going to use it, right? And then never mind VMware. We're not going to have, VMware isn't going to be in the conversation, because all these applications are going to be deployed on OpenStack and developed on OpenStack. Now I go into my CIO, my CTO's office, and I say, I'd like to make an investment. We want to do this training. We want to bring in these people to deploy OpenStack at scale. And he goes, what about the risk we talked about? And you go, well, you know, 100 of our newest apps are already running on OpenStack. It's not a big deal. We have 20 guys that know OpenStack. In fact, they deployed it. They have the scar tissue. It's not a big deal. And now he starts writing a check and saying, how much cheaper is this than VMware? And so VMware's taken notice. That's what I was talking about. Is now VMware, they can go like, we do OpenStack too. You know, we have an OpenStack. So they've been kind of brought to the table, because all these large organizations are looking for ways to cut costs, and OpenStack is a great way to do that. So, but it does take some scale. If you told me you had 2 servers and 20 VMs, I'm going to say it's probably more complicated to deploy OpenStack for you than to manage 20 VMs, right? Deploy Puppet or Chef. If they die, they'll be easy to configure and build again. It's not a big deal. You don't need to orchestrate a lot of resources. Sorry, long answer.
No, that's fine. Unless anyone else has another one, I've got a follow-up. Where do you think OpenStack is going to go next?
I don't know. The community's too big.
So one of the things that you're going to do now is define like what core OpenStack is.
Yeah.
And then sort of split, like there's a whole lot of projects right now that are trying to be part of OpenStack. And so a lot of what the technical committee is working on is defining like what's the minimum thing that you need to have to be an OpenStack provider.
just to use the branding to say you're OpenStack. And some of that is an interoperability play, because that's the idea, is having OpenStack in all these places is the ability to have that interoperability. But the reason I say I don't know is there's I mean, you saw all the vendors, right, and all the choices that can be made. I think there's an expansion of those choices, and now some of those choices are being able to use VMware and OpenStack, or integrate my existing Cisco architecture, my Nexus switches, configure those programmatically using OpenStack or Neutron or whatever software that's provided to me by Cisco. So I just think that it's each of these different companies sees a different vision for OpenStack. Again, that's the beauty of the foundation, right, and the core. But beyond that, it's going to continue to do this. I think choices will get harder and harder. But the beauty is there's all those slides about messaging systems and databases and stuff like that. I think that a year from now, 2 years from now, we're having this conversation. We don't talk about how it works. Just like nobody asks VMware, like, explain to me how messages pass between these two services. It's bulletproof. It just works, right? It was automated. I had a tool to deploy it. I paid my subscription, and I think OpenStack is going in that direction too. Where unless you're deploying it at scale and you really care what goes into it, as long as the cake is good, you don't really care into the batter.
I think it's going to follow a lot of the same kind of curve that Linux followed. In the early days of Linux, it could do all these great things, except you had to know how to compile it all into the kernel, and you had to know how to, manage everything yourself. And then distros started coming out that made it a little bit easier, and then a lot easier. So there's distributions now that make it easier, but they're still not terribly flexible or whatever. They're still growing. And that's one of the things that's been recognized among a lot of technical committees, technical leadership, is we're focusing so much on the developer, making it easier for the developer to contribute. We're not working on making it easier for people to consume, making it easier to deploy, making it easier to use. And I think they're going to try and pull back the featureitis. Like, let's add this, and let's polish what we got so far.
Yeah, I know. So when I was with Canonical, that was kind of their big value statement. Is like, you look at all this like stack analytics, and you see all these contributions to OpenStack, where a lot of their focus was just make it bulletproof, make it work for the customers that are using it at scale on top of it. I agree. I hope it doesn't fully go the direction that Linux went, where you have these religious wars. Technically we're all Linux, but now I care if you're wearing a different hat than I'm wearing. So I hope that it doesn't go in that direction, and that there's but at the very minimum, at least the Linux kernel stands to gain from it, right?
Well, that's the thing. OpenStack is more like the kernel versus Ubuntu or Red Hat or CentOS or something. OpenStack is more the kernel than something like Piston or Nebula or one of the other packaged versions of OpenStack would be more like a Linux distro. They have their own.
I should have done a couple slides on that just to cover that. There's too much content. But Piston, Nebula, kind of how ready to consume versus deployment tools versus hardware with embedded OpenStack on it, the different directions that the different organizations took. And what's interesting is now we're getting further enough down the line where you're seeing businesses do this or take off based on their business model.
There was one other correction. You said that when it started, that Swift was more mature because it was used in production. Right?
Yes.
And that's true.
Okay.
But Nebula was being used in production at NASA just for a very specific use case.
Good point.
They had scientists with all their satellite data, and they needed to analyze it, so they'd fire up 10,000 VMs, do all the Hadoop or whatever crunching of that data that they needed to do, and then they would just disappear. And that was how Nebula worked. And it was was on the cloud servers team at Rackspace then, and like,
Yeah.
no, we kind of want them to stick around for a while.
Yeah.
I don't think our customers want them to just vanish.
No, you're right, based on the
And
use
so
case.
That was
Yeah.
what we, ended up having to add into it, but it was in production, but for a very specific use case. And that's what happens with OpenStack, is you have different people who say, I could use it to do this, and they want to pull it in that direction, and everyone else says, slow down, we need it to do these things too.
Yeah.
So,
You're right, and the conversations I was having was with banks and service providers, and for them, yeah, different use case. It wasn't exactly what they wanted, but they're like, but that Swift thing, I have a lot of these pictures of checks that are going to hang around for a long time, and I want to put those somewhere. So, yeah, early on, we're doing a ton of Swift, and Nova, we were throwing the Anso Labs team at it to do development.
One of my best memories is meeting with the Anso Labs people. They were all having beers and fish tacos down at the Cove. That's where a lot of the initial plans were done.
Over beers, it's comforting.
This is a great idea. Ask me another one.
What did we do last night?
Well, I guess it worked out.
Question. So I noticed the next conference is in Paris, and I noticed also one of the platinum partners is Huawei, which is a huge Chinese telecom.
Yeah.
On the OpenStack board, is there any discussion of standards or standardization as far as from an international perspective, like engineering standards, or is that not a consideration, or is that
I'd ask a developer.
What kind of standards?
just like hardware standards, or not hardware standards, but standardization for internationalization?
Yeah, oh yeah, there's a.
It's already part of it.
I just
It's
saw
already part of the conversation.
I just saw the number. The Juno
Yeah.
release has 50-something thousand new translations added just in this release.
Wow.
So there's a big, and they do have very strict rules when you contribute code that's customer facing, that displays anything. It has to be wrapped in, the localization code, and they have different ones for log messages, because you don't always translate those.
Sure. So we won't have we'll have an Ethernet jack kind of model, rather than every country has a different power plug.
Yeah, well,
But
that's-
when dealing with
But I think
the
it-
platform, right?
I'm not sure, I haven't played with it, but I know the idea is like with the dashboard, the Horizon
Right.
dashboard. If your system is set to French,
It
and there's
also
a French
localization.
translation available, it will appear in French. And, I know they have Japanese too. There's a whole bunch of people
Oh.
from NTT who are working
Yeah.
on OpenStack and provide a lot of Japanese translations.
Yeah, Yahoo Japan. It's huge in Japan.
It's amazing. It's just amazing to me how many people contribute, because maybe they're not a super programmer, but they know how to speak two languages, so they can.
Oh, look at, Vance, they're mostly developing, right? They're a French company. Morantis, they're various, I can't tell you which former Soviet republics, but,
A lot of people from Poland,
a lot
France.
of Poland.
Yeah, a lot of Polish people there.